Whoa, what just happened? A plate fell and it broke? Had this happened in an Indian home, your mother would reward you with a pasting ranging from flinging a lamp to a laptop or even another plate. But considering this very situation in our lives, we tend to make various predictions, such as whether this plate that falls from a certain height will break or no. And today, we're able to teach computers exactly how to make such predictions. Let's take a look at this intuitively. Consider we were to plot a graph of plates on the x and y axis based on their hardness and height from which they were dropped. These ones because of low hardness and being dropped from a considerable height will break, and these ones here with high hardness levels but being dropped from a low height will probably survive and not break at all. Now say we have a plate somewhere right there and we were to predict whether this plate would break or no. Based on the information that we have, with a quick guess, we can tell that this plate will probably break. Now say for a moment the plate was somewhere there exactly. In such a case, we can implement a supervised machine learning algorithm known as the kNN. Supervised means that you give your computer some clues in advance. In this case, the data about the hardness and the height of the plates and whether it'll break or no. This example above falls under the category of classification problems because our problem set is to classify whether the plate will break or not break. The NN in kNN are the nearest neighbors, and k is an integer value that we decide. These are the k number of neighbors we would like to refer to in order to decide whether this plate will break or not. Thus, if we chose the value of k to be, say 3, this corresponds to the 3 nearest neighbors. But how do we find out which are the 3 nearest neighbors? Let's atomize this together and intuitively understand what is it that the mathematics in this algorithm is really trying to do. What the kNN algorithm does is that it measures the distance from this point in the graph to all the other points in the scatter plot. The distance is measured using the Euclidean distance formula, which says that for 2 points x1, y1 and x2, y2 in a two-dimensional space looks something like this: the square root over the sum of the square difference between the x coordinates x1 and x2 and the square difference between the y coordinates y1 and y2. What the algorithm then does is that it ranks all the distances that it has computed in the ascending order. And since the value for k we have chosen is 3, it discards the rest and then it begins to vote. When voting, it checks for the highest frequency of the classes among these that we have here. We have 2 votes for the not break class and 1 vote for the break class. And that's exactly how our algorithm arrives to the conclusion that this will not break. The plate will survive and so will we. Otherwise, you know who's going to unleash the wrath, right? Hope you enjoyed this intuitive explanation of the kNN algorithm used for classification problems. Do share your feedback and recommendations in the comment section below. Stay tuned for such videos where we break down things into their most indivisible form, atom by atom.